Prerequisites.
Carbon and its compounds. For better understanding of this lesson, you must know some important terms, that is, what is an element, atomic number, and how to write the electronic configuration. Having the general knowledge of fuels which is used in our life. What are soaps and detergents? What is its functioning and uses?
Learning objectives.
Introduction of the carbon and its compounds. Formation of bonds in carbon, covalent bond formation. Versatile nature of carbon. Saturated and unsaturated carbon compounds. Chains, branches and rings of carbon. Homologous series of carbon. Nomenclature of carbon compounds. Chemical properties of carbon compounds, they are combustion, oxidation, addition and substitution reactions. Properties and uses of ethanol and ethanoic acid. To study about the soaps and detergents.
Introduction.
In our daily life, we are using many of the things like food, clothes, medicines and books are all based on this versatile element carbon, and also all living structures are carbon based. So we shall be learning about an element of carbon and its compounds. Occurrence. The amount of carbon present in the Earth's crust has only 0.02% in the form of minerals like carbonates, hydrogen carbonates, coal and petroleum. And also the amount of carbon present in the atmosphere has 0.03% of carbon dioxide. In spite of this, a small amount of carbon is available in nature. Bonding in carbon, the covalent bond. Most of the carbon compounds are poor conductors of electricity. The melting and boiling point of acetic acid is 290 K, 391 K, and ethanol is 156 K, 351 K. From this data, the force of attraction between these molecules is not very strong, since these compounds are largely non-conductor of electricity and does not give rise to any ions. Elements forming ionic compounds achieve by either gaining or losing electrons from the outermost shell to attain noble gas configuration. In the case of carbon, atomic number is 6. It has 4 electrons in its outermost shell and needs to gain or lose 4 electrons to attain noble gas configuration. Case 1. It could gain 4 electrons forming C4- anion, but it would be difficult for the nucleus with 6 protons to hold on to 10 electrons, that is 4 extra electrons. Case 2. It could lose 4 electrons forming C4+ cation, but it would require a large amount of energy to remove 4 electrons, leaving behind a carbon cation with 6 protons in its nucleus holding on to just 2 electrons. To overcome this problem by sharing its valence electrons with other atoms of carbon or with atoms of other elements to form molecules by sharing electrons in this manner. The shared electrons belong to the outer shells of both the atoms and lead to both atoms attaining the noble gas configuration. Let us see some examples of formation of simple molecules by the sharing of valence electrons. Formation of hydrogen molecule. The atomic number of hydrogen is 1. Hence, hydrogen has 1 electron in its K shell and requires 1 more electron to fill the K shell. So, 2 hydrogen atoms share their electrons to form a molecule of hydrogen H2, and each hydrogen atom to attain the electronic configuration of the nearest noble gas, helium, which has 2 electrons in its K shell. The shared pair of electrons is said to constitute a single bond between the 2 hydrogen atoms. In case of oxygen, An atom of oxygen has 6 electrons in its L shell and it requires 2 more electrons to complete its octet. So, each atom of oxygen shares 2 electrons with another atom of oxygen to constitute a double bond between the two atoms. So, oxygen molecule is formed by the 2 shared pair of electrons. Formation of methane molecule. We know valency of hydrogen is 1. Carbon is tetravalent because it has 4 valence electrons. In order to achieve noble gas configuration, carbon shares these electrons with 4 atoms of hydrogen. The bonds are formed by the sharing of an electron pair between 2 atoms are called covalent bond. These bonds are very strong within the molecule, but intermolecular force are small. This gives rise to the low melting and boiling point of these compounds. Since the electrons are shared between atoms and no charged particles are formed. Such compounds are generally poor conductors of electricity. Versatile nature of carbon. Already we saw how many things we use contain carbon. In fact, we ourselves are made up of carbon compounds. The numbers of carbon compounds formulae are recently estimated to be about 3 million. The nature of the covalent bond enables carbon to form a large number of compounds. 2 factors noticed in the case of carbon. Carbon has the unique ability to form bonds with other atoms of carbon, giving rise to large molecules. This property is called catenation. These compounds may have long chains of carbon, branched chains of carbon, or arranged in rings. In addition, carbon atoms may be linked by single, double, or triple bonds. The carbon-carbon bonds is very strong and hence stable. This gives a large number of compounds with many carbon atoms linked to each other. Carbon compounds are linked by single bonds between the carbon atoms are called saturated compounds. Compounds of carbon having double or triple bonds between their carbon atoms are called unsaturated compounds. Since carbon has a valency of 4, it is capable of bonding with 4 other atoms of carbon or atoms of oxygen, hydrogen, nitrogen, sulfur, chloride, and many other elements, giving rise to compounds. The reason for the formation of strong bonds by carbon is its small size. This enables the nucleus to hold on to the shared pairs of electrons strongly. The bonds formed by the elements having larger atoms are much weaker. Saturated and unsaturated carbon compounds. We have already seen the structure of methane. Now we will see the structure of ethane, ethene and ethine. Ethane. Compounds formed between carbon and hydrogen is ethane with a formula of C2H6. In order to arrive the structure of ethane molecule, step 1. Link the carbon atoms together with a single bond and then use the hydrogen atoms to satisfy the remaining valencies of carbons. Step 2. 3 valencies of each carbon atom remain unsatisfied, so each is bonded to 3 hydrogen atoms. Ethene. Compounds of carbon and hydrogen has the formula C2H4 and is called ethene. In ethene, each carbon atom gets 2 hydrogen atoms and 1 valency per carbon atom remains unsatisfied. This can be satisfied only if there is double bond between the 2 carbons. Ethyne. Compounds of hydrogen and carbon has the formula C2H2 and is called ethyne. In ethyne, triple bond is necessary between the 2 carbon atoms are known as unsaturated carbon compounds. Chains, branches and rings. We have seen structure of methane, ethane and ethylene. Now we shall study about the butane and another saturated compounds. Butane. In butane, 4 carbon atoms and 10 hydrogen are present. Step 1. Make the carbon skeleton with 4 carbon atoms. We can arrange the 2 different skeletons. Step 2. Fill the remaining valencies with hydrogen. We get butane structure. Both these structures have the same molecular formula C4H10 but different in structures are called structural isomers. In addition to straight and branched carbon chains, some compounds have carbon atoms arranged in the form of a ring. Cyclohexane has the formula C6H12. All these carbon compounds which contains just carbon and hydrogen are called hydrocarbons. Among these, the unsaturated hydrocarbons which contain one or more double bonds are called alkenes and triple bonds are called alkynes. In the hydrocarbon chain, one or more hydrogen can be replaced by halogen, oxygen, nitrogen and sulfur such that the valency of carbon remains satisfied. In such compounds, the element replacing hydrogen is referred to as heteroatom. These heteroatoms and the group containing these confer specific properties to the compound regardless of the length and nature of the carbon chain and hence are called functional group. Some important functional groups in carbon compounds are halo, alcohol, aldehyde, ketene and carboxylic acid. Homologous series. The presence of a functional group such as alcohol dictates the properties of the carbon compound regardless the length of the carbon chain. For example, the chemical properties of methanol, ethanol, propanol and butanol are all very similar. Hence, such a series of compounds in which the same functional group substitutes for hydrogen in a carbon chain is called homologous series. If we look at the formulae of successive compounds like methane, ethane, propane, butane and pentane, all these are differed by a CH2 unit. As the molecular mass increases in any homologous series, a gradation in physical properties is same because the melting and boiling point increases with increasing molecular mass. Solubility in a particular solvent also show a similar gradation. Nomenclature of carbon compounds. The names of compounds in a homologous series are based on the name of the basic carbon chain modified by a prefix phrase before or suffix phrase after indicating the nature of the functional group. Naming a carbon compound can be done by rules. 1. Identify the number of carbon atoms in the compound. If 3 carbons are in compound, give name propane. 2. If any functional group is present, it is indicated in the name of compound with either a prefix or a suffix. 3. If the name of the functional group ketone is to be given a suffix, the name of the carbon chain is modified by deleting the final E and adding the suffix ONE, propanon. 4. If the carbon chain is unsaturated, then the final ANE in the name of the carbon chain is substituted by ENE, propene or YNE, propine. Chemical properties of carbon compounds. Most of the fuels like coal, petrol, CNG and LPG we use are either carbon or its compounds. Let us see some of the chemical properties of the carbon compounds. 1. Combustion. Carbon burns in oxygen to give carbon dioxide along with release a large amount of heat and light. These are the oxidation reactions you have studied in first chapter. C plus O2 gives CO2 plus heat and light. Activity 1. Take some amount of carbon compounds like camphor and alcohol one by one on a spatula and burn over the flame. Observe the nature of the flame and note which one is produced smoke. Place a metal plate over the flame and observe the camphor deposition on the plate in case of any of the compounds. Reason: unsaturated compound, that is camphor, will give a yellow flame with lots of black smoke. This results in a sooty deposit on the metal plate. Saturated hydrocarbon means alcohol will produce a clean flame. Activity 2. Light a Bunsen burner and adjust the air hole at the base to get different types of flames, because limiting the supply of air results in incomplete combustion of even saturated hydrocarbons, giving a sooty flame. Oxidation. Activity: take ethanol in a test tube and warm it gently in a water bath. Add a 5% solution of alkaline potassium permanganate drop by drop to this solution. The color of potassium permanganate does not disappear when excess is added. In this reaction, alcohols are converted to carboxylic acids, that is adding oxygen to the alcohol. Hence, they are known as oxidizing agents. Oxidation reactions are already studied in first chapter. Ethanol in the presence of alkaline KMNO4 gives acetic acid. Addition reactions. Unsaturated hydrocarbons add hydrogen in the presence of catalysts such as palladium or nickel to give saturated hydrocarbons. This reaction is commonly used in the hydrogenation of vegetable oils using a nickel catalyst. Oils containing unsaturated fatty acids should be chosen for cooking. Substitution reaction. Chlorine is added to hydrocarbons in a very fast reaction. Chlorine can replace the hydrogen atoms one by one. It is called substitution reaction because one type of atom or a group of atoms takes the place of another. CH4 plus Cl2 in the presence of light to give methyl chloride plus HCl. Some important carbon compounds: ethanol and ethanoic acid. Properties of ethanol. Ethanol is a liquid at room temperature. It is also commonly called alcohol and is the active ingredient of all alcoholic drinks because it is a good solvent. Ethanol is also soluble in water in all proportions. Uses. 1. Ethanol is used in medicines such as tincture iodine, cough syrups and many tonics. 2. Consumption of small quantities of dilute alcohol causes drunkenness. 3. Long-term consumption of alcohol leads to many health problems. Reactions of ethanol. Reaction with sodium. Ethanol reacts with sodium to produce hydrogen gas and sodium ethoxide. Reaction to give unsaturated hydrocarbons. Ethanol on heating with excess concentrated sulfuric acid at 443 K to give ethane. Concentrated sulfuric acid acts as dehydrating agent which removes water from ethanol. Properties of ethanoic acid. Ethanoic acid is commonly called acetic acid and belongs to a group of acids called carboxylic acids. 5 to 8% solution of acetic acid in water is called vinegar and is used widely as a preservative in pickles. Reaction of ethanoic acid. Esterification reaction. Activity. Take some amount of ethanol, glacial acetic acid along with a few drops of concentrated sulfuric acid in a test tube. Warm in a water bath for a few minutes. pour this solution into a beaker containing 20 to 50 ml of water. Here we can observe the sweet smell from the resulting mixture because esters are formed in the reaction. These esters are sweet smelling substances. This reaction is reversible reaction. So this reaction is known as soapanification because it is used in the preparation of soaps. Reaction with a base. Ethanoic acid reacts with a base such as sodium hydroxide to give a salt and water. Reaction with carbonates and hydrogen carbonates. Ethanoic acid reacts with carbonates and hydrogen carbonates to give salt, carbon dioxide and water. Soaps and detergents. Activity. Take some amount of water and also oil drops in 2 beakers and label them as A and B. To beaker B, add a few drops of soap solution. Now shake the 2 beakers vigorously for the same period of time. Leave the beaker for some time and observe. You can observe the oil and water layers separately in both the beakers. This is effect of soap in cleaning. The molecules of soap are sodium or potassium salts of long chain carboxylic acids. The ionic end of soap molecules thus form structures called micelles, where one end of the molecules is towards the oil droplets while the ionic end faces outside. The soap micelle thus helps in dissolving the distance in water and we can wash our clothes clean. Activity. Take 2 beakers and add distilled water in one beaker and hard water in another beaker. And also add soap to both the beakers and shake. Observe which beaker will give foam. Distilled water will give foam. Hard water does not give foam with soap with the calcium and magnesium salts which cause the hardness of water. To overcome this problem by using detergents as cleaning agents. Detergents are generally ammonium or sulfonate salts of long chain carboxylic acids. The charged ends of these compounds do not form insoluble precipitates with the calcium and magnesium ions in hard water. Thus they remain effective in hard water. Detergents are usually used to make shampoos and products for cleaning clothes.
Summary.
Carbon is a versatile element that forms the basis of all living organisms and many of the things we use. This large variety of compounds is formed by carbon because of its tetravalency and the property of catenation that it exhibits. Covalent bonds are formed by the sharing of electrons between 2 atoms so the both can achieve a completely filled outermost shell. Carbon forms covalent bonds with itself and other elements such as hydrogen, oxygen, sulfur, nitrogen and chlorine. Carbon also forms compounds containing double and triple bonds between carbon atoms. These carbon chains may be in the form of straight chains, branched chains or rings. The ability of carbon to form chains gives rise to a homologous series of compounds in which the same functional group is attached to carbon chains of different lengths. The functional groups such as alcohols, aldehydes, ketones and carboxylic acids best characteristic properties to the carbon compounds that contain them. Carbon and its compounds are some of our major sources of fuels. Ethanol and ethanoic acid are carbon compounds of importance in our daily lives. The action of soaps and detergents is based on the presence of both hydrophobic and hydrophilic groups in the molecule, and this helps to emulsify the oily dirt and hence its removal.